Alright, back again with another draft physics video presentation. Glad that's over with. Anyway, comments, and then we'll probably do something on Bill Gaede. He did a debunk of D. Hilster and Ken Wheeler and kind of threw everybody in the same category, and it was just terrible. Actually, it's hard to watch. But anyway, just hatchet job, as they say. Didn't really get to any specific issue that could possibly make a difference, and whatever. So I'll just jump through it, and you'll just see it's just a bunch of disconnected notions that are easily counter-argued. Anyway, Mr. Keebler, I always feel so self-conscious when I don't leave a message. Well, yeah. For which I watch every video, but there are times when I have nothing to add or debate. Yes, yeah, so I understand. Just know that I greatly appreciate your work on spreading the real science instead of the buffoonery that so many are spewing to the masses. Yes, I appreciate the appreciation, but again, I'm just a robot, and I'm just doing this because I find it annoying and irritating. And I have to keep making videos because somehow you can't just point out how, look at the glaring flaws in their theory, okay? No energy for the two most important things that happen in physics, gravity and magnetism. They show us no diagram of where the energy comes from. It's just magical. It's just right there. Actually, the conversation should almost be over right there. And we just say, oh, they're so full of shit, aren't they? How can they tell us they have it all understood and they have this model and all this crap when they don't have energy for the two most important forces existing? I mean, just, it's that bad. And then I provide you a rational explanation of how this is just little quanta of energy, and it moves the speed of light, and then there's these little matter bits that have charge, and that just means they interact with the energy in two distinctive ways, and it all fits together and works just fine. Don't pay any attention. Not that you don't, but people. And you have to go to all this effort to try to, bang these ideas home, and it's just like, well, why? Why should it take all this work? But this Mugu guy, T3, is an example. At 17 minutes, it's very interesting that the way of understanding the photon is basically, your way of understanding is basically the same as Ken Wheeler. Well, I'm going to delete your comment just because that's just an outrageously stupid thing to say. Ken Wheeler thinks a photon is doing this, and it's doing this, hyperboloids. He calls it a coaxial circuit, counter space, all kinds of horse shit that has nothing to do with thinking of it as a single little quanta of momentum in a direction. He thinks it is doing some kind of crap, up and down, all over the place, doing all this wacky crap in some sort of field. Again, conventional physics gave us this stupid model, and there's no evidence that photons radiate anything other than landing somewhere. It's like they're saying it's a meteor, and the meteor is vibrating. There's fields vibrating perpendicular to the meteor's motion. There's no evidence that that's happening. All right. For example, in this video, he is explaining the same basic idea. So there's no same basic idea. He doesn't believe there is such a thing as a photon. He says it overtly. And again, when he's talking about whatever light is supposed to be, it's in these amorphous, vaporous, etherish bullshit. As you did here, unfortunately, Ken uses a lot of non-conventional terms. He uses terms that make absolutely no sense. There's no such thing as a dielectricity. Okay, there's electricity and there's not electricity. There's no dielectricity. And to fully grasp his point of view require the view of other videos of his. Yes, I've watched 100 or more of his videos. So this bullshit that you have to watch more videos to understand is just that bullshit. He keeps wanting to pervert science into a fucking metaphysical religion, and it's just crap. So fuck you for associating me in any way with anything. Yes, me and Ken Wheeler might agree that water's wet, and that's the end of our agreement on anything physical. So fuck you. Anyway, any idea what's the most conservative answers to quantum mechanics rather than hidden variables? Well, that's not an answer to quantum mechanics. Quantum mechanics, frankly, okay, especially back in the 30s, wasn't about entanglement, and hidden variables is a counter argument to some notion that particles don't know who they are until one of them decides to be something, and then particle B decides to be the opposite. And hidden variables is the counter argument, which is there's right and left hand gloves that pop out of things, and obviously they're in pairs, so then if you find the right hand glove, you know that the other glove is a left-handed glove, and that kind of thing. It doesn't really have anything to do with quantum mechanics in the sense of wave theories. So I don't know whether this is some sort of rhetorical question. I just don't know the nature of it, and I guess I'm arguing it's not really properly phrased. And you really can't get any more conservative than recognizing that, well, the more conservative answer to quantum mechanics is there's no such fucking thing as entanglement anyway. There's no two particles that are left-handed and right-handed on purpose in any way. There can be particles that one is shot left and one is shot right. Okay, now those two particles have something distinctly different about them. One has energy, they have energy going in the opposite direction. But you wouldn't say they're twins for that reason. You wouldn't even say they're left and right-handed gloves for that reason. You would just say, yeah, they're going in opposite directions. Duh. Alright, so I think I'll delete that too. Yeah, frankly, just not very useful. Alright, doesn't get to any experiments or any why do people believe the crap they believe. Alright, so here's the Bill Gaede's video. I don't know what this Torrica, magnetic Torrica, Wheeler, Thornhill, and then D. Hilster. Now the funny thing about this was when it had like 25 views, it had 14 likes. Okay, so it seems that because Bill Gaedes mentions D. Hilster, and he's in the icon, that D. Hilster rated the video up. Now I can't say for sure who did it, but that's what I'm surmising, that D. Hilster imagines that any reference is a positive reference. You know, that kind of thing. Any fame, you know, is good. You know, any, however that phrase goes. You know, the idea is to have somebody pay attention. Alright. So, Bill Gates' videos always begin with nothing. You know, like 2 minutes of nothing. Which is a little bit stupid. Alright, so that's he's having a meeting in Africa. Yeah, which is funny. I feel like everybody's going to go rushing there. But anyway, okay, so he complains that the other dissidents don't define terms or something. And I think they do. You know, a lot of them are etherists, so yeah, they're stuck with some. Well, the ether is just the ether, you know. They don't really give it any definition. But this idea, you know, anybody's going to make a particle argument, I think they're clearly going to argue there's stuff, the particles, and the stuff in between the particles is nothing, okay? It's nothing. There's something, and then there's nothing bits. And the space is nothing. And he's all hung on this. when it's not any different than his silly rope theory in the sense that the ropes have to be separated by something. I don't think Bill spends very much time explaining there's empty space between the ropes. Why should you have to point that out to me? Yeah, I get it. There's rope and then there's non-rope. There's non-anything. There's nothing. Well, what's so complicated? Yeah, and he just goes on as if this is a reason to say somebody else's theory can't possibly be right because they didn't say there's space. Where the somethings aren't, where there's no something, well then there's nothing. That's space. Space is nothing. It's not complicated.
Infinite. They use that word infinite when they shouldn't use it at all. It's in irrational term, as I discussed last time.
Right, okay, but that really doesn't get to their particle theory. So, yes, fine, I also find that obnoxious. He also believes in the small earth theory and the earth is growing. So, yes, he throws in a bunch of other crappy pseudoscientific nonsense. And, he probably should keep all of those separate on separate channels or something, because there's no point in mixing with just what is absolute crap. So his theory that the universe is infinite, he probably should just shut the fuck up and deal with his mechanisms. But again, his mechanisms rely on some ... after, he goes G1, G2, and then it's ... like, oh, then there's G3s and G4s and G5s and infinitely down, and then all of a sudden you do get into a space problem. Then you can make the space argument. So if you want to make an argument that they don't account for empty space, you could just make the argument that as soon as you talk about infinite forces, well, then there is no empty space, because your infinite forces are going to end up filling every piece of space there is. So yeah, that doesn't make much sense.
They confuse infinitesimal with zero.
Well, this kind of semantics bullshit, I don't see how any of this makes any difference. So, who cares? Yeah, I don't see any huge tragedy in that mistake. Who cares? Yeah.
Bob the Hillsters, he's the father in the father and son team, and he writes in his book some of the foundations, some of the things that he believes serve as the foundations to his book. And the first one is what an object is, which is good.
All right, well, this whole thing of defining objects, obviously as soon as you say there is something, you've already defined there's objects. So I don't, you could just argue that, okay, it's a particle theory, meaning, yes, elementally, that's just made up of these things, these little bits of momentum, things that have momentum. So you could argue that if it can't exchange momentum, if the thing has it and can't exchange it, it's irrelevant. It can't mean anything in anything called a universe, because a universe is a functioning thing that requires there to be an interaction. So if it can't interact, it can't be qualified as a something. So you can go ahead and invent as many nothings that somethings that have no interactive capacity you want, and it would be irrelevant. They're just ghosts, so who cares? But again, this distinction about having to have objects, I don't know how you don't have objects. Even when you say there's an ether, it's an object. That can vibrate, so you can be easily analogized to an ocean, and you just say, well, yeah, I'm not going to play some game that the ocean isn't an ocean. Yes, physically, the ocean is made up of molecules, and I can go further down or deeper, but for the sake of understanding, you don't need more than that. Again, Bill Gaede doesn't explain what his ropes are made out of. He doesn't explain where they come from or any of that crap, so why is he expecting anybody else to do more than he's done?
Next one is what is motion, and the third one is what exist is. And these are the notions that Bob has of these concepts.
Alright, so let's read some of this. The universe is made up of objects that move. Things. Yes. Some things. Okay, I think that's fair enough. That's my basic assumption. And I go on to define objects, and then I define motion. So, yeah, I don't know if they need all these strict definitions. Um, I define what objects are, what we detect with our senses. That's kind of silly because obviously our senses don't detect a lot of the stuff we see. We detect them with something superior to our senses. What instruments detect? Well, yeah, so just say it that simply. We detect consequences. We detect effects, frankly. I define motion as a change of an object's position over a given period of time. Good, fine. So there, are we done with this minutia that couldn't possibly matter? I mean, obviously we're talking about a device that has moving parts. And that's it, moving parts. So let's just talk about the moving parts, because they're the only parts that are relevant, frankly. One category is which we detect with our senses. We detect Earth, Moon, stars. We detect atmosphere, water. We can also detect with what is real with instruments. Right, instruments that convert it into something we can sense with our senses. But the bottom line is we're detecting interactions that cause a change. If they don't change anything, we can't detect them. So, yeah. When we do, we can say these things are real. I define motion as the change of an object's position over a given period of time. Yeah, but some things don't really change position in the sense they just go from A to B to A to B to A to B to A to B. So that definition could get mushy if you don't understand it. I mean, if you keep looking when it's at B, it's not moving. Keep looking when it's at A, it's not moving. It's not moving much, could be the argument. But any movement, yes, any change in position over any period of time would mean something is a something. Okay, I'm going down won't help me any. Well, let's see what the thumbs up and thumbs down are now. So it has 11 now, so it didn't gain any. Okay, from the time it had like 20 views. Well, that was the Bill Gaede's channel. Yeah, so that's my mistake. He has the video on 2 different channels. So the other channel had the thumbs uppers.
Words, okay? And that's how he's going to use them, I guess, throughout his book. And he says, what is real? In my book, Gravity is Not Free, I start with one basic assumption. The universe is made of objects that move. And that's interesting because...
Alright, so I don't know where he got that, but in my book, Gravity is Not Free, I start with... So he went from this sentence all the way down to this sentence, so I don't get that. But anyway, enough of this. This minutia just couldn't matter.
Differences between irrational, unscientific definitions and the ones that form the foundations of physics. Okay, and
yeah, so again, the foundations of physics are just understanding concepts are real things. They do happen. Things have properties. So if I say the word wave, everybody can get that a wave is a concept, a thing that happens to mediums. They can have a perturbation that perturbates through them. And so, this isn't where things fail, okay? These kind of vocabulary games and aren't where it fails. It's when they take a standard concept like the idea of wave and then say all of a sudden they made a laser beam wave or some other thing like that, which makes no sense. So the quantum mechanics definition of a wave, where the wave goes in all directions and then it decides after it lands somewhere what road it really took, that kind of crap.
we need location. It's a static concept. Exist means an object that has location. If God wants to exist, he doesn't have to be believed in, he doesn't have to be disbelieved in. All he has to do is have location. And before that, he's got to be an object. If he's a concept, if he's intelligence, if he's a spirit, if he's love, then God does not exist.
Yes, well, again, this exists where? In the universe or outside of the universe? So again, this could get into the whole if the universe is God's creation, he wouldn't live in his creation. His mud pie would be separate from him, so he would be under different rules because he's in a different universe. Blah, 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 blah. But again, who cares?
By definition, for the purposes of physics, he can continue existing in religion and motion in two or more locations. Okay, so those are the scientific definitions with which we form the foundation.
Right, and again, what's so complicated? So why not just say, look, let's have a conversation where we understand there's some things and then there's nothing, so there's empty space, and just say to the ether as well, if you think, there's no such thing as empty space, then how do things change position? Or make some kind of reasoned argument that, okay, we really can't have a conversation because, that's really not what I'm recognizing as function. Function is things changing positions, not having the same position and somehow perturbating. Can't do both.
Of physics, and definitions are absolutely critical. You can't do physics without defining terms, because what is science? Rational explanations. What is physics? Rational explanations.
Yes, I agree in the sense that but all of this could just be argued from the point that the conventional physicists are the ones who broke the language first. There was no doubt about what space meant before Einstein turned it into something. Okay, it was nothing. Okay, space, empty space, it was empty space. It was nothing. It was void of stuff. And the distinction was kind of obvious. The black stuff doesn't do anything. It doesn't have any interactivity. And the stuff that's not black, that we can see or detect in some way, and the stuff that moves and has momentum and can exchange it and can interact, is distinct from the space, right? Clearly two different things. Paper and what we write on the paper, to use a crude example.
The mechanism. You got to explain the mechanism. And for that, you need language. I'm sorry. You need language. And you need to define your terms, especially the ones that are going to destroy, make or break your theory, right? Okay.
I think they did that well enough, in the sense they make a distinction between the active players and that's it. The active players are separated by distance that doesn't have an active player in it. They're clearly saying that, essentially.
This is Bob's world, okay? And he's got a son, David the Hilster. And it's nice to see father.
Okay, so now he does a little rag on that and has his own kid pop into the screen for a second, blah, blah, blah. So I don't know why he's not doing the videos with him anymore, but whatever. I thought that was kind of a good interaction. But anyway, 2 hours a week, it's not that much work.
Okay, so we're going to have more particles coming up, from their view of the world. Okay, so
little pause. Slight pause. Small pause. I should be back. I do so hate living with people. Anyway, moving on. Such.
what kind of theory did they propose? Well, they proposed that the G, especially this G1 and G2, G3, N1 and N2 particles, and so it's a particle world. Okay, it looks
right, and there's nothing intrinsically wrong with a particle world. Now, obviously, I'd say there's something wrong with their particle world, and that they're denying basic experiments that define these things as differently. That you have to account for charge. You can't just say something like there's a nucleus and nucleon or whatever they call it. Yeah, all that crap doesn't make any sense. It doesn't fit the evidence. They really can't explain the evidence in any kind of rational manner, and so it's wrong for those reasons, specific reasons to their exact assertion. It doesn't mean all particle theories are wrong. just as Einstein's bent space doesn't mean that all ether theories are wrong. I'd say they all turn out to be wrong because it's just wrong. There's no such thing.
In my opinion, I'm just going by what they say. Maybe I'm wrong in what I'm presenting.
You're wrong in what you're presenting in that, again, their idea is a 300-year-old idea. It's not like it hasn't been part of the conversation in physics in different points in its history. And it still exists as a thing called mock gravity in the sense that it's still a solid idea in terms of explaining gravity. So, deal with those arguments.
I don't want to misrepresent them, but I'm just going by what they say. They say there's G1, G2s, N1s, and N2s. There it is. That's what I put last time.
Right, and so you say this is a fair approximation of their theory, that they just say they're all mixed up and they all just do whatever. And that's not what they say. So if I did rope theory, but just making a bunch of ropes going in all different directions and tangling, there, I've done it. I've finished rope theory. I've fairly argued it's stupid. Look, it's all a big knot in the middle. The universe doesn't look like that. So, yeah, it's stupid. I mean, that's all you're doing here. It's not even close to a reasonable approximation of what they're asserting.
Now, I don't think I'm misrepresenting anything here.
I think you are profoundly misrepresenting it in that these G2s are going the speed of light squared, which is preposterous, and the G1s are going the speed of light. And these other things don't go any speed, particularly, as far as I know, until they're hit by some kind of particle that pushes them. So how does this diagram illustrate any of that? Oh, that's right, it doesn't.
And the issue here is, what is the black stuff? And of course, since Bob...
So again, an amazing statement. Like, it wouldn't even occur to me that I'd have to explain the black stuff. So, I mean, I've presented my theory and pointed out that no, all there really is there's two kinds of force. Electron force, proton force, plus force, minus force, north force, south force. And there's two kinds of matter, electron and proton. And that's all there are those four elements that make up the elemental function of the universe. And those things are separated by that black stuff. Space, empty space. Okay, that's... So what's the problem? When did that become inconceivable?
The Hillster does not believe that the universe includes space, just includes matter. He's not going to...
So again, this is a statement where, well, because he didn't say there's, oh yeah, and by the way, there's empty space between the things. Okay, that's how you can identify the thing. The thing's not an N1 if it fills all of space. So obviously it doesn't fill all of the space. It has a concise position, means also size. Its position isn't everywhere. So yes, it has a size. Wow, who knows what its shape is. But yes, it has a position and a size. I didn't know I had to explain that to you.
To define what that black stuff is, and or deal with it at all, apparently.
Again, I haven't seen a Bill Gaede's video where he shows his ropes and then says, oh, by the way, there's empty space between the ropes. I haven't seen that video. So, Bill, you're guilty of your own crime. The defined crime is you're guilty of it. So you're not making much sense. So this is such a desperately poor effort at critiquing.
Yes, he doesn't care about it.
You don't care about it. Again, where's your video explaining there's empty space between the ropes, the threads?
And so, yeah, I've got a little bit of problem with that, with him skipping over space. Space is what the big problem is.
I mean, frankly, it's not even close to any problem. It's not the big problem. The big problem is they think the universe is N somethings and G somethings all the way down, which is, there's no evidence for any of that. There's no evidence the big universe is duplicated in the small universe, and then the small universe has a smaller universe underneath it, and the universe has a smaller universe underneath it. There's just no evidence of any of that.
Okay, And so what are the problems with what they propose? Okay. Well,
Twice the speed of light squared. Well, there's a big problem right there. And having a force acting at that speed and then pretending, oh, there wouldn't be any evidence of its action in our universe. Somehow there wouldn't be any leakage from that mechanism of motion to our world, and we wouldn't recognize that, oh, we can just send a bunch of these supersonic speed kind of particles and have instantaneous conversations. Well, nearly.
this is what I have synthesized as far as what I can tell. There's probably a couple more problems, but this is what I'm going to cover today. Oh, sorry, got the wrong one there.
We'll jump ahead a little bit, see what he's. So this is another really bad paraphrase of De Hilster's theory. So he's saying that that they say photons are doing this wavy thing, and they don't say they're waving like this. They're not moving side to side. The wave is a representation of how many particles there are. So they say that the photon is, a bunch of, like, a million little bits right here in this little line, and then, well, I could draw it. Maybe I'll do that. Maybe I will. Let's see. Alright, I guess I should first point out that Bill's really not understanding particle gravity or Lesage kind of theory, in the sense that he keeps negating the fact that you can have two objects, and that there are, if you create straight line forces, that they will, in fact, block force to each other. They will shadow each other from forces. So force will still be able to hit something this way, but it won't be able to hit it this way, in the sense that this object will absorb that force reflected and absorb the momentum this way. And that's how it's going to work. And so there would be a lack of force here on this surface, because this is obviously absorbing the force, stopping it. And it's that kind of a simple argument that there's a shadow created by this object. And the shadow is darkest, closest, and lighter the further away you go. And that's the basics of a particle theory. And he just kind of ignores that that's what would happen. So if I fill a box full of little BBs with momentum, and then I put two objects, any old objects, inside the box, the two objects will be forced into each other. And that's just a fact of our physical universe. And he hasn't dealt with that fact, that a particle theory can create a mechanism of momentum exchange or interaction that creates attraction. That's a fact. Big nose. Yeah, it's kind of funny. What the hell is that? It's kind of cool. I look entirely different. But anyway, I could try that with other objects. I have to remember that. Anyway, impress myself. So where was I? Something to do with oh yes, the photon. So, the De Hilsters make photons way more complicated than necessary. So they're arguing, I just take this marker, I just don't like it. Anyway, that, the photon is one photon, like one ray of light. Alright, it's some sort of crap where, there's fewer of them, and then fewer of them, and fewer of them, and then more of them, and then more of them, and then we'll get back to a solid line again. And a photon is some big pile of a bunch of these little bits of momentum that go from being a lot of them to very few of them to a lot of them, and that would be the wave, that they make photons into. There's no wave. So there's no reason to do this. There's no reason to contrive all this crap, because there's no wave. all there is a frequency. That's all we have evidence of, is that the momentum comes at a frequency, a wavelength, a distance between. So there's a length of time moving the speed of light that is a distance created between them, wavelength, and that there's a frequency, that they come at a timed interval. And that's it. There's no hard evidence of anything else. These are the little bits of momentum. You don't need all this crap in between, because there's no evidence of a little bit of a photon, like the photon gets stronger and the photon gets weaker and the photon gets stronger. There's no evidence for any wave-like character to a photon. As Feynman says, it arrives as a frickin' clump. Feynman said it's not a wave. And if it's not a wave, it's the only alternative is realistically a particle, a thing, a clump, a corpuscle, as Newton called it. Yeah. So again, people keep thinking Newton was a etherist, when, clearly he wouldn't have said corpuscle if he believed in an ether. Light, come on. It's humidity or something. There's always something. So is there anything else that I need to clarify? Yeah, I should have done a better job of doing the Lesage gravity, but anyway. Yeah, so that's enough. We'll just go back to the video. Sorry, I'm underperforming today. Alright, back to the videotape and such.
I'm not sure in what way I'm misrepresenting what they're saying. So I don't know. Again.
Well, again, I guess I'd go with their drawings rather than yours. That might help. Your interpretation of what they say. What else might help? I don't know. But that would help. Alright, so let's jump ahead a little.
Blue and red are the same. I'm just showing blue and red as directions only. They say as soon as...
Kind of funny, but yes, the blue and red that works for magnetism has different forces. So, it's just, this is almost drawing pictures relevant to my theory.
As they hit an object, they scatter. Okay? A lot of them scatter because they hit atoms. Okay? So we're going to be hitting atoms that are going to...
All right, so this is a kind of a key part of physics that a lot of people aren't getting, is that this idea of a scatter is really an exchange of momentum. And the exchange is in the real sense of exchange. Something inside of something going this way is exchange for something going this way. So when it hits, this loses this way. So there's a clear equal but opposite reaction satisfied. But there's also the action that you've now changed the thing that made the exchange. So the change is real in terms of it's... There's kind of an asymmetry in the sense that you end up with a momentum this way, where it seems like it's an extra, when it really isn't. But yes, the baseball itself does move.
Scatter, and some go right straight through and go out the other side. So
yeah, so if you just stayed here and said, okay, so when there's only one baseball in the picture, the forces are equal, because there's no shadowing of the force, there's no changing of it. But if I add another baseball over here, well, then the game is different.
We've got a little bit of magic there because they don't explain why or how so far. Maybe they will in their book or whatever, but right now...
Well, explaining why or how doesn't require any more effort than to say, look, we already know the cosmic background radiation exists. So whatever's doing that, you could argue is doing gravity, is doing these extra little bits that are hitting the baseballs.
They don't explain how these particles, some of them go through and some interact. I guess they go through the interstices. I guess that's what they're referring to.
Yes, obviously we already have, most of us have agreed, maybe even you, that atoms have a lot of empty space in them. So if you're shooting very small things, you could go through some atoms without ever hitting anything. That's not that complicated.
I don't know. But that's how they get concentrated in the center of the ball, and that's what they're going to call, that's what they're going to call gravity. Okay? So what's the problem that
So that's not what they call gravity, and yes, the fact that it creates a center of gravity, that's seems kind of obvious. There's pressure all from all directions that has to pass through one center point, and yeah, that's a problem.
I see with this? Well, you got particles coming from every direction, so I cannot imagine anything traveling straight to begin with.
So he can't imagine something traveling straight, yet somehow his ropes can maintain their straight integrity most of the time, except when they're jump ropes. I mean, really, his own counter argument is so ludicrous. He has this stupid thread theory, and then the threads wrap around each other, creating a rope, and the rope creates torsion. And then in a magnet, somehow the whole rope is jumping, swinging like a jump rope. you know, I can't imagine that.
Okay, and here I put a little circle next to it. This is a region of space next to the ball. And, particles are coming to that region also from every area.
Like, obviously, they're not coming to that region through the baseball. The baseball is absorbing some percentage of those particles. So, again, you just didn't get it. That obviously there were particles that were on their way to this region in space, and the baseball is in their way. And they're not going to get there because they're going the speed of light. They're going to hit the baseball. The baseball's going to not move at the speed of light. It's just going to move really, really slowly. And so obviously the force that was going right for this space isn't going to get there. Now that isn't too hard. That's not too bizarre a concept. And yet you just ignored it. And it's fundamental to understanding. And you just you drew your arrow right through the baseball like it wasn't there.
Universe. And the question is, do they form atoms? I mean, aren't we going to have atoms formed in there?
So again, this argument that I have to explain creation now again. So where did your ropes come from? I mean, it's a moot point. The point is that force exists. Now, a thing that D. Hilster maybe needs to point out to you is that the argument of interaction. You could argue that force bits don't hit force bits. Now, we already know that you can't shoot light at light and create reflections or anything. Light doesn't interact with light. So I can't make a light bulb interact with another light bulb. The light will not interact. But the explanation for that could either be that, okay, it can never hit each other somehow, because they're on different lanes of the universe or some kind of crap like that. Or another explanation is if I make these two things the same color and I bang them into each other and they reflect, the outcome would be exactly the same as if they missed each other. And you can do that with all interactions. The interaction is purely kinetic, that is, nothing's lost, there's no blending. So one thing goes in this way, one thing will come out that way, and one thing will be going this way, and one thing will come out that way. So it'll all be no different than if they missed each other. The misses will look just like the hits. And it's only when you get things colors that you can sort of identify what happened. So for the sake of gravity, it doesn't matter color. And the fact is the force doesn't interact in a way that changes the universe. So if the interaction doesn't change anything, it can't be called an interaction. That means it can't be relevant. So you're kind of just missing that there's no need to be confused about straight lines. They're all straight lines.
Somehow. And so I got a problem with this because, all these particles are coming in, they're just going through in that region, and there's nothing to stop them, they claim, and that's why there's no gravity in that region. Okay, but then we have to find out how an atom forms.
They're not saying there's no gravity in that region. What they're saying is that there's no difference in the field. So if there's no baseball there, that region is going to be equal on both sides. The force is going to be equal. If there's nothing absorbing the force, then the force is even. But it's not like there's no force. They're not saying there's no G1 particles. They're saying there's just as many coming from one way as there's coming from the other way. So nothing happens.
forms, because they're saying that the atom is made of G1 and G2 particles, and the nucleon as well. So they're saying, let's see if I can find it here again.
Yeah, their diagram of the atom is, I haven't seen one. So yeah, I don't know how they think it functions.
Is this the one?
Whatever. We'll jump ahead a little.
They say everything goes inside. More particles come into an object than come out.
Yeah, so this is always a problem, having to explain the difference between kinetic and potential energy, how potential is stored, and the Earth is doing sort of the same thing in that it has equilibrium. It's hot, but it had to get hot. Somehow it had to be heated, and the heating it did require energy not going where it was going because it had to get caught or stuck in the Earth. But again, that argument can be explained in the sense that it's a dynamic system, and so it's always doing that. It's always changing the time between actions, and changing the time changes the effect. I mean, if I change when I shoot a bullet at a moving target, I'm going to change whether I hit it or I don't hit it. That kind of thing. So. Yeah, so this is a sort of a valid point, but it gets into more complex physics in recognizing that even when a system is at thermal equilibrium, the fact is that in any one moment of time, it's out of equilibrium. That is, it's oscillating its equilibrium, and that's all you need to create gravity, because objects are only going to feel the reflection or the absorption of a force, and they're not going to feel the counter force. It's raining again. I should have. I forgot to do water exchanges, but anyway.
And that happens with every object in the universe. So no object in the universe is really sending more than what it receives. It's receiving more, more and more particles. So these particles should be exploding. I mean, they should.
Yeah, right. So you're just saying, okay, they don't have any counter explanation when you really haven't asked for the explanation. So, and again, I would argue that you clearly, in a system, in a direction, you're always, if the train is stopped, okay, and you're going to have to make it go with some things that have momentum, and it's not until it's already running that the things you're going to have to add are equalized. That is, they won't have to keep them. That's a better analogy. I have to think about it. But anyway, I'm thinking of throwing things into a bucket on wheels or something. You know that the first few you throw in there, they don't go where they were going. So there's clearly a deficit in a direction. There's clearly stuff that isn't getting where it should be going. And that's the only point that needs to be understood.
It'd be filled with particles. We should be getting heavier every day, because particles are just coming in.
There's stuff moving inside the Earth every day, and that's the only part you need to understand, is that all the movement, even my hand doing this, okay, represents energy that should be, technically, flying through space, going somewhere. Technically, if it was free. And it's not free. It's caught here doing this. It's moving this matter instead of going where it was going. Okay, so that's all you really need to understand, is that there's activity on the Earth every day, and all of that activity represents stored energy, energy that was captured in a direction. It didn't get where it was going.
To objects and to the center of gravity of every object, and fewer are leaving. So I think that's a fatal flaw in there.
Yes, right. There's no infinite battery, so you can't just keep filling the battery. Okay, I would agree, but that's not what gravity's actively doing. That's why the Earth continues to be hot. if you gave it back instantaneously, then there would be no problem because you'd keep going from hot to cold to hot to cold in some obvious way. And it's not doing it in an obvious way. It's doing it a little tiny bit at a time. And that's all the fluctuation you need to keep creating a negative pressure. The past movement can't account for the current movement. The movement of the matter bits has to be constantly maintained by constantly capturing force. How was to say it? Yeah. But it is capture and release in the end, but only in the end.
System, plant, yeah, completely failed. I don't know. I don't know how they're going to answer that one, but in their book. But okay. And you know, one of the things you look at is, you know, before you read a paper, you usually read the abstract, and you look at the abstract. If it makes sense, you say, oh, I'm going to read this article. But if you see only nonsense, or you see so many fatal flaws.
So again, somebody could read your abstract and do the same thing and just say, what do you mean, ropes, and okay, threads, and then tangled threads, and then ropes, and then from every atom to every atom, and then every electron to every electron, and every proton to every proton, or some other kind of bullshit. It doesn't make any, yeah. I mean, I wouldn't have to go very far into the abstract and start asking questions that just don't seem answerable. Like, oh, so you're saying the universe is more rope than it is actual things. I mean, why don't we just do away with the idea of a end of the rope? That there's something at the end? Like what? And somehow this little something, it has the ability to torque a big giant rope.
The abstract, then you don't read the article. And right now, the abstract that's out there for their particle model is lacking, and I'm being kind.
Yeah, well, it's lacking, yes, I would agree, but not the things you're arguing. The minutia you're arguing isn't the important stuff. The important stuff is this G2 crap of something moving the speed of light squared. Like, where's your evidence of any of that crap? The crap that you still believe. You think there's something coming out of a magnet that's going around inside the magnet. You believe the same theory in a sense that you think there's motion inside of a magnet, which there's this no evidence of any motion around a static magnet. Because you don't understand. All right, moving on.
And again, the fact that that more particles enter the atom, the atom or the whatever object you.
All right, so this goes back to the point about they think the atom is being held together by the same principle of gravity. So they think the whatever the G1 energy inside the atom that's supposed to be the representator of the electron is somehow moving all the time, and it's somehow being held with some sort of gravitational force into that pattern. And that would be what the G2 particles are doing. So I mean, the G2 are mitigating gravity, and gravity is creating the momentum that atoms have, something like that.
Have in there, that's already quite fishy. But then they have a big problem because we have what I call spaghettification. I don't call it. It's.
All right, so then it gets onto a subject that doesn't matter. Spaghettification, spaghetti. But anyway, it's just a completely tangential and only applies to some notion where you have very strong gravity where it's going to make a difference between the head and the tail of something. And of course that happens. And so he sort of makes an argument that somehow this is a problem in the real universe, when it's not a problem because the amount the gravity changes for the size of the object is so tiny that it can't possibly create any noticeable spaghettification. So we're clearly not spaghettified, but there is a difference between the gravity at the top of my head and the gravity at my feet, but it's a tiny difference in the gravity. So he's not even accounting for the fact that we just have a number, 10 meters per second, Well, that's for the surface of the Earth, and it's not an exact number. It's a rounded off number because different places have different amounts of precise gravity. So again, he's just demonstrating that he doesn't really understand how gravity works, that it changes as you move. Every inch it's a different gravity, but it's just a tiny difference.
This is a term from the black hole guys. You know, if you heard it ever, you know, you'll see something that looks like this. Let's see if I can find it. Where is this?
This is really interesting.
And it looks something like this. This is how they illustrate it, and that means if you fall into a black hole, and here all I'm saying is, I'm not talking about black holes, I'm not proposing black holes, I'm saying that you fall feet first.
All right, so you're bringing up a subject which really isn't relevant.
Into a hole, into a center of mass, okay?
Yes, and just this is just a logical argument. The gravity does incrementally change at different locations. So matter, an atom at this location is going to be affected by a less gravity than an atom at this location, and that's just a fact. So I don't know where D. Hilster's arguing that that's not true. So again, this is sort of a straw man argument because I don't think D. Hilster's saying that's not true.
Okay, so why don't we modify this a little bit so we find what the problem is with this, all right? What we're going to do, we're going to put a black ball in there now, okay? We're going to put a third object in there. Okay?
Right, and the gravity for the third object is going to be different than the gravity for the smaller object, and so he's using objects as if they're literally 2 inches off the Earth when they're not going to be. They're going to be hundreds or thousands of miles away from each other, which means the gravity will be substantially different. So once you go 4,000 miles or 8,000 miles off the surface of the Earth, you've already reduced the gravity in half or more.
And so what happens now, if the Earth wasn't there, we know the two balls get closer to each other. The distance between them decreases. Now we put the Earth, and they both fall to Earth, and you can say they fall as a system.
But they don't. So you could say it, but you haven't shown where anybody else said it. So they really don't fall as a system because they're two different objects, and each atom is still a single atom. Gravity's a nuclear force. You know, that's just a fact. But there will be a force between the two objects, but it's not going to overcome great distances. So if these are 10 feet apart and they only weigh 100 pounds, it's the attraction they have is going to be so infinitesimal it's not going to mean anything compared to the gravity of the Earth. So this is just moot bullshit.
On Earth knows what they stand for. See, they were put in there by hand because they had to match the equation. Now, okay,
all right, so now he's talking about the big G in the gravitational equation, and it's just there to create units. It doesn't have any other purpose. It just makes it tells you this is what percentage of a kilogram it is, or this is what percentage of a some velocity term. It just doesn't have anything to do with any real thing that is in space. There's no G in space. There just isn't. And all it's used for mathematically is to create a consistency to a unit that we've already decided is the unit we want the answer in. So depending on what unit you want the answer in, like feet or miles or kilograms or something, we'll decide what G is. So it's not meaningful.
Try and make this as simple as possible.
All right, so this is where he just goes through his own derivative of the gravitational constant, which just doesn't mean anything because again the final answer is in a form that frankly can't mean much to anybody. It's not in something like calories or degrees. So just more mathematical crapola, which he hates, but he put it in a video anyway.
just a couple weeks
All right, so
ago.
this is Ken Wheeler stuff, dielectric, dielectricity. So all attraction and repulsion is governed by dielectricity. So again, just it's not a real word. It doesn't exist. Nobody can know what it means because there's no such thing as dielectricity. It's just can't mean anything to anybody scientifically literate. It's not a word. It's got no definition that's rational. That has anything to do with some sort of special religious word. Alright, so this is probably enough of a video. Yeah, I should have picked the points better to argue. Because again, I thought his critique was superficial and doesn't get to the... Look, if you want to make a critique of particle gravity, then just make the Lesage critique and point out how, yes, well, it does gravity perfectly, but it's no good because it creates a drag problem. Or, bring up a real issue, not this fake issues. So anyway, till the next time and such. Yeah. That's the plan anyway, if I can get out of here alive.